Video for the special triangles lesson. If you are interested in retaking the quiz on this, it'll be on Friday, March 13th. So I'm going to do the first half of this, and I'm going to turn the other half over to Mr. Kubicek for you. So when we look at the special triangles, we have two types of triangles. We have the 45, 45, 90, like the four shown here, and then we have the 30, 60, 90 triangles, like the first four on your paper. So I want to focus on the 45, 45, 90 at first because the pattern is a little bit simpler, and these tend to just be a little bit easier than the others. So we'll start with the easy and move into the harder stuff. Alright, so the first thing you want to look at is the pattern for a 45, 45, 90 triangle. I'm going to draw it right here in the center of this so you can see it. The pattern for a 45, 45, 90 works like this. The short side, one of the short sides, if you notice they're both 45-degree angles, which indicates these two sides are going to be the same, and then the one opposite the 90 will be larger. But opposite the 45, if we call that short side, we don't know what it is, but we call it x as some unknown value. And then opposite the other 45, it's going to be the same value, so that one is also x. But then opposite of 90, the pattern is basically based on that short side, whatever it's equal to, we call it x, but the long side is x times the square root of 2. So we're going to use that pattern to solve all the sides of every one of these triangles. So the first thing you want to do, and I think is a good habit, is to look at the triangle you're given and put the pattern on the triangle. So usually I suggest find it and put it on the inside. So opposite the 45-degree angles, when I mean opposite, I mean if you draw a line pointing to the side from that 45-degree angle, that's an opposite side. So this one is opposite of this angle. And then opposite the other 45 is also an x, and opposite the 90 is x squared root of 2. So with the pattern drawn in on this triangle, then the question then becomes, what side are we given, and how does it help us find the x value for this triangle? In this case, you can see we're given the left side over here. We're told it's 10. And once we put the pattern on there, you can see that this is a side that is just equal to x. So for this triangle, our value of x is 10. That means we can use that to plug in the values for the other sides. For example, the bottom side here, where it says x, well, if x is 10, this side is 10. And opposite of this one is supposed to be x times the square root of 2. Well, x is 10, so this is 10 and times the square root of 2. See, this one is a pretty standard one because it fits the pattern exactly the way it's supposed to.
Nathan Smith, Brittany Mettler,
I'll wait for the announcement.
Dave Sahara, Ryan Gesso, Brett Kuznar, Dante Jacobs, Kaylee Rabatin, Gianna Malika, Larry King, Marissa Dietrich, Audrey Kopich, and Greg Martinez to the office. Also, Katie Sutton in the office, please.
Alright, sorry about that. I know you guys are used to those announcements anyway. So. But when we go back and look at this triangle, then this triangle fits the pattern perfectly.
Alyssa Gallagher, Fallon Davis, and Katie McCarty stop in the office.
What I mean by that is the two sides that are supposed to be regular numbers are in fact regular numbers, and the one that is supposed to have a square root does have a square root. So this should turn out to be one of the easier ones because when the pattern fits perfectly, it's usually very easy to figure out what x is and very easy to figure out what each side of the triangle is. Alright, so let's go to number 6 and we'll put the pattern on it as well. Opposite the 45s are x, and opposite the 90 is x square root of 2. So if we look at it this way, the side that is supposed to have a square root does. So if we're trying to figure out what x is for this one, well, it says that x is supposed to be the number in front of the square root of 2. So in this case, x is 14. So if x is 14, we'd be able to fill in these other two sides because they are just equal to x. So both of them are 14. So as you might imagine, these do get a little bit more difficult than this. The question is how do you make one of these more difficult? The answer is that, what if the pattern doesn't work perfectly? The pattern's always going to be the same. Opposite the 45s are x and x, and opposite the 90 is x square root of 2. But the problem is, like in the case of number 7, the side that is supposed to have a square root does not have one. The only thing that's nice about that is that if the side that's supposed to have a square root doesn't have one, the sides that were not supposed to have one will. So it works exactly opposite. So you either get the pattern straightforward like we did in number 5 and number 6, or we're going to end up having them opposite like we will in number 7 and, as it turns out, in number 8. So if you can tell right away that the one that's supposed to have a square root does not, then it tells you the pattern is backwards. So what I have in number 7 is a situation where we have the side that is x square root of 2 equaling 24. Okay, what I would do to figure out x, because it's still what is x for this problem, I'm going to divide by the square root of 2 on both sides, and that'll cancel this. And I get x equals 24 over the square root of 2. But the problem with this is that you're not really supposed to have a square root in the bottom, so I do what's called multiplying by conjugate, which is taking it times the square root of 2 over the square root of 2. See, this thing is still equal to 1, but what I'm trying to do is get the square root on the bottom to go away. What happens when you take a square root of a number times itself like that is you just get the number that was under the square root. So on the bottom it just comes out to 2. And on the top it's just 24 times the square root of 2. So then what I do in one last step is to figure out x's final answer. I take 24 divided by 2 and it's 12. Square root of 2. So my answer for x is 12 square root of 2. But the issue with this is, of course, then that, like, you know, are you going to have to do this every time the square root of 2 side is a whole number? It isn't that way, because you're going to use a pattern reasoning to do that too. If you think about it, all we really did to get this answer was we took this number, divided it by 2, and put it next to the square root. And that'll happen every single time. So when you get this thing that is supposed to be a square root and it's a whole number, what I'll do is I'll just divide it by 2 and put it next to the square root, and that'll be what x is. So for this problem, x is 12 square root of 2, and that means these sides are 12 square root of 2 and 12 square root of 2. So obviously it's a little bit tougher because you're getting something that isn't exactly immediately easy to see like numbers 5 and 6 are. But if you're looking for a pattern for these, if your whole number is located in a place that's supposed to have a square root, just divide it by 2 and put it next to the square root, and that's what x is equal to. And then you can go back and plug in the x's for the other sides. So let's look at number 8 and see how it's similar to number 7 then. Okay, if we put the pattern back on the triangle, again, opposite of the 45s is x, and then opposite of the 90 is x squared root of 2. So in this case for our triangle, x is 13 square root of 2. So it's pretty easy to tell what x is. The question is how can we use that to figure out the rest of this? Well, the second side over here is equal to 13 square root of 2 because it's equal to x. So what do we do with this side though, where it's supposed to be x times the square root of 2? Well, if you think about it, okay, what we're saying is x times the square root of 2. But we know x is itself is 13 square root of 2. That's x. And then we have to multiply it by this square root of 2 again. Well, just like before, down here in this proof I showed you, when you take the square root of a number times the same thing, it just equals that number. So it's really 13 times the square root of 2. This side is 26. Okay, so if we go back and look at number 7 for comparison, you notice that in number 7 we were given the square root of 2 side as a whole number. That meant that the pattern is backwards, which means that the two sides that were supposed to be whole numbers have square roots. And like I said, if you want to know what x is, you would just take this number and divide it by 2 and put it next to the square root. That's where we get the 12 square root of 2 part. Well, looking at number 8, we have that same situation, right? The sides that were supposed to be whole numbers are square roots, and it turns out that the side that was supposed to have a square root is a whole number. So when you go to do this, look at it this way, right? Imagine you were given the 26. If you divided it by 2 and put it next to the square root, you would have the other two sides. So it's literally the exact same problem, they just give you a different side to start with. Alright, so then let's go up and look at the 30, 60, 90 triangles. Incidentally, if you want, this would be a good time to look at the back of the review paper if you want. Maybe pause the video and take a look at numbers 13 through 16 and see what you can do with those, because those are examples of 45, 45, 90 triangles. Section 5.8. Just show me section 5.8. So if you want to go ahead and do that way, that's a good idea. But I'm going to continue on here with the 30, 60, 90 examples right here. So the issue here is that there's a different pattern because this is a different kind of triangle. So I'm going to put the 30, 60, 90 pattern here for you, so you can see what you're dealing with this one. So this is the 30, the 90, and the 60. We always base it off the shortest side of the triangle, which is opposite the 30 degrees. We'll call that short side X because we don't know what it is. Opposite the 90, it's just double that much, so 2x. And then the one opposite of 60 is going to be x times the square root of 3. So whatever our short side is, if we can figure it out, we can plug it in to get the other sides. So let's put the pattern on the triangle for number 1. Opposite of 30 would be this way, is x. Opposite of 90 is this side, 2x. And opposite of 60 down here, x square root of 3. So, like I said, for every one of these triangles, you want to see if you can figure out what your x value is. In this case, the side that is supposed to be x is the one we're given, and it's equal to 8. So for this one, our triangle, our x is 8. So we can do this one. This is 2 times x, or 2 times 8, which is 16. And opposite of the 60 is supposed to just be whatever x is times the square root of 3. Our x is 8, so this is 8 square root of 3. So again, this is one that fits a pattern perfectly. The sides that were supposed to be whole numbers are, and the one that's supposed to have a square root does have a square root, which is exactly what you want. Alright, let's look at number 2. Again, put the pattern on the triangle. So in this case, again, what is our x value? Well, you can see the side that's supposed to be square root of x square root of 3 is 10 square root of 3. In other words, the number in front of the square root is x. So in this case, our x is 10. So we can go to the side that's supposed to be equal to x and call it 10, and the one that's supposed to be equal to 2x and call it 20. Once again, the pattern fits this one perfectly. 2 whole numbers where they're supposed to be, and a square root where it's supposed to be. So naturally then, when you're going to make these more difficult, the difficulty comes from when the pattern doesn't fit perfectly. So if we go to number 3, opposite of 30 is x, opposite of 90, 2x, and opposite of 60, x square root of 3. And you can see right away that in this case, the side that's supposed to have a square root has a whole number, which means that the pattern is backwards. So just like the other triangles, when the pattern is backwards, the side that will have a square root, or supposed to have a square root, will not, and the sides that aren't supposed to have one will. So it means that these two sides of the triangle will end up having square roots next to them. But just like before, you're going to end up dividing this whole number, but in this case, since it's a square root of 3, you'll be dividing by 3 and putting it next to the square root of 3. So for x, for this problem, I want to divide this by 3 and put it next to the square root. So x is 6 square root of 3. And divide by 3 and put it next to the square root. So this side that is x is just 6 square root of 3 then. And the side that's twice that much, well, 2 times 6, 12 square root of 3. So we're on to the last problem here, where again we're dealing with 30, 60, 90, and if we put the pattern on it, we're given a pattern that isn't exactly what we want. The side that's supposed to be 2x is 20 square root of 3. So we can figure out what x is equal to. It's not too bad. X is going to be, well, this is 2x is 20, so it's going to be 10 square root of 3 for x. So we can go back and fill in the side that x is equal to and call it 10 square root of 3. But you can see what's happening here. The sides that are supposed to be whole numbers are square roots, which means that the square root side will be a whole number then. So the question is, how do we do this? Well, if you think about it this way, we could look at the old pattern here and say, how did we get from the whole number to x? I divided it by 3 and put a square root next to it. If I was going to go backwards, I would multiply it by 3 and drop the square root. So if I just multiply x by 3 and drop the square root, I'm going to find out that x is 30. Another way you can do it is to say this side is supposed to be x square root of 3, and x itself is 10 times the square root of 3, and then we have another square root of 3 brought down. The two square roots of 3 multiplied by themselves are just going to give you 3, and your answer for this side is 30. Alright, I'm going to leave the rest of this to Mr. Kubicek. If you'd like to do the second page first, and then come back and check your answers, I think that's a good idea. Of course, you can always check the video for more explanation of each problem. We're going to give you a list of other practice problems if you want to look at it. I'm going to put it down here at the bottom of your paper right here. So if you want to look at some additional problems out of the text, these are the ones that you can go back and look at again. They're on page 372. It will be numbers 1 through 3, 5 through 7, 9 through 11, and 13 through 15. Okay, it's important. Just find the missing sides of the triangles. Don't worry about the variables. This is what we had you do when we first did this lesson. But just go back and look at it again and see if you can do it.